Daniel Webster from Lime Microsystems, and today we're using the LimeSDR radio card to demodulate GPS satellite data. GNS signals are widely used in many applications, including the ubiquitous sat-nav for cars, as well as location and time synchronization systems for mobile networks. Precision GNSS receivers benefit from the programmable bandwidth and high ADC rates available with the LimeSDR. The LimeSDR is configured as a low IF receiver using the internal numerical controlled oscillator to down-convert the signal to baseband, and then decimating the signal to reduce the amount of data that has to be processed in Octave. The low IF configuration has the advantage of making the receiver relatively insensitive to DC calibration issues associated with zero IF receivers, but it also gives a few dB extra increase in sensitivity compared to zero IF. In this demonstration we're using a low noise active patch antenna. The antenna is mounted on the office window here and is sufficient sky coverage for typically 2 to 4 satellites with some slow fading. The Octave software is running on one of Lime's Ubuntu workstations. We have found that Octave 4 is more stable on Ubuntu than on Windows, with large data volumes required by GNSS applications. The Octave software begins by capturing data from the LimeSDR card. We then show the FFT of this data after it's gone through a raised cosine digital filter. The software then begins to look for the satellites which are visible to its antenna, and here we can see 4 satellites are visible in the code domain. The data is then demodulated, as you can see here. Because of the high quality crystal which we use on the LimeSDR card, the data remains usable over many seconds of captured data. The data includes synchronization signals as well as the satellite almanac data, which is required for detailed positioning work. As extras from the LimeSDR, we also have measurements of phase versus time, of Doppler frequency versus time, as well as early-late events as they occur. This measurement is sufficiently sensitive to actually measure the frequency variations of the crystal oscillator and the change in Doppler shift as the satellite moves.